balance the following equation. So you have sodium phosphate reacting with potassium hydroxides, forming sodium hydroxide and potassium phosphate. So I have sodium present. I can see the polyatomic phosphate here, and it does make it through intact, so that means that I can count that as a single thing. I have potassium present, and then I have hydroxide polyatomic that also makes it through intact, so I can also count that as a single thing. Sodium on the left, I have 3. Sodium on the right, I have 1. Phosphate left, there's no parenthesis with a multiplier, so that means I only have 1 phosphate on the left. And phosphate on the right, I don't see a parentheses or a multiplier, so that means I also only have 1 phosphate. The potassium on the left, I have 1. And then potassium on the right, I have 3. Hydroxide on the left, no parentheses, no multiplier, so I have 1. Hydroxide on the right, no parentheses, no multiplier, so I have 1. Sodium and potassium are both metals, and so they would come first in Minho, so I get to just pick which one I want to go ahead and balance. Since I wrote sodium first, I'm going to balance sodium first. I have 1 on the right-hand side, I want 3, so I'm going to go ahead and add a 3 coefficient here. That changes my sodium count to 3, but it also changes my hydroxide count on the right-hand side to 3. And now potassium and hydroxide are not balanced. Potassium is a metal, so I'm going to fix the metal first. Potassium on the left, I have 1, but I want 3, so I'm going to go ahead and add a coefficient of 3 in front of that compound. That will give me a 3 count for potassium on the left-hand side, and then it will also fix my hydroxide at the same time. Now that everything is balanced, I can go ahead and give myself my victory lap here. On blend, the coefficients for the compounds that we did not end up putting any numbers in, I do still need to include them, and those are invisible ones, and so on blend we would type the ones. Predict the missing product of this equation. So the thing that we need to do whenever we are predicting a missing piece of an equation is we're going to look to see who is present. So I can see magnesium, fluorine, lithium, and then carbonate CO3. On the right-hand side, lithium and fluorine are already accounted for. So that means that my missing compound is just going to be the things that are unaccounted for. And then I can see that I already have coefficients here for the entire reaction, which means that this is balanced. So I just need however many are going to be present. So magnesium, I have 1. And then carbonate, CO3, I'm just going to have 1. So this would be MgCO3 as my missing product. Balance the following equation. So I have carbon tetrafluoride and bromine reacting to form carbon tetrabromide and fluorine. So I'm going to list out everybody that's present. That would be carbon, bromine, and fluorine. Carbon left, I have 1. Carbon right, I also have 1. Bromine left, I have 2. Bromine right, I have 4. Fluorine left, I have 4. And fluorine right, I have 2. So bromine and fluorine are both unbalanced, and they are from the same section of Minho, being nonmetals other than hydrogen or oxygen. So I can pick whichever one I want to fix first. I'm going to go ahead and pick bromine. I have 2, I want 4, so I'm going to have to add a coefficient of 2 here. That multiplies my number of bromines up to 4, which is what I wanted. And now fluorine is the only thing that's unbalanced. I have 2, I want 4. I'm going to add a coefficient of 2 here that will multiply my number of fluorines up to 4 as well, which would make everything balanced. Now, when we are just writing them out, we would leave these spaces blank, but on blend, we do need to put in those actual numbers. They were invisible ones, and so on blend, you would just type in the ones. Predict the missing reactant of this equation with the provided information. So I can see that I have phosphorus and 3 of something reacting with, or producing, sorry, this diphosphorus trioxide. So from the right-hand side where I have a completed equation, I know that I'm going to have phosphorus and oxygen appear. And I know that phosphorus already appears on the left-hand side, so that means I would just be dealing with oxygen here. Now, to balance this, I see that this is P4, and on the right-hand side it's 2. So that means that there must be a coefficient of 2 here in order to get that to balance, which would mean I would have a grand total of 6 oxygens, initially 3, but now 6 oxygens on the right-hand side. I have a coefficient of 3 here, so 3 times what gives me 6? 3 times 2 gives me 6, so this has to be O2. And so now everything is balanced. This has to be my missing reactant, and that would be my final answer there. Balance the following equation. Silver nitrate and copper react to form copper to nitrate and silver. So I'm going to go ahead and I'm going to write out everybody that's present. That would be silver. Nitrate makes it through intact. That's the NO3. So I can go ahead and count that as a single thing. And then I have copper. Silver on the left, I have 1. Silver on the right, I have 1. Nitrate on the left, I have 1. Remember that the polyatomics would need to be in parentheses and then a multiplier on the outside if I had multiple of them. That is not here, so that means I only have 1 NO3. And then nitrate on the right, I have 2. That's that multiplier on the outside of the parenthesis there. Copper on the left, I have 1. Copper on the right, I also have 1. So the only thing that is not balanced is that nitrate. I have 1, but I want 2, so I'm going to go ahead and multiply by 2. When I do that, that fixes my nitrate, but it messes up my silver. So I'm going to go ahead and have to fix silver as well with a coefficient of 2 on that right-hand side. So once that is done, then I can go ahead and do my victory laps and have this as a balanced equation. Now remember that on blend, you do have to write in these invisible coefficients. Those invisible coefficients are 1s, so you would type in 1s in front of those compounds there as you finish your problem. Predict the products of this equation with the provided information. So I have rubidium nitrate and beryllium fluoride, and I am producing 2 things. So I'm going to be able to say that this is going to be a double replacement reaction. I know that it's a double replacement reaction because I have a compound plus a compound going to a compound plus a compound. So that means that I need to switch partners. So rubidium is going to have to now be bonded with fluorine, and beryllium is going to have to be bonded with nitrate. So I'm going to go ahead and figure out what the charges for those are going to be in order for me to balance them out so that I can make the correct compounds. Rubidium is in column 1, which means it has 1 valence electron. It would lose that 1 valence electron, so it would have a charge of positive 1. Fluorine is in column 7, so that means it has 7 valence electrons, so it has 7 and 1's 8. It would steal 1. So if I crisscross those for charges, I would end up with RBF as my final compound. Then I have beryllium and nitrate. Beryllium is in column 2, meaning that it has 2 valence electrons, so it's going to have a charge of positive 2. And then nitrate is a polyatomic ion. So that means that it has a defined charge. So I would look on the inside of my periodic table. I'm going to see that nitrate has a defined charge of -1. Crisscrossing charges for subscripts. This is going to end up being that I get 1 beryllium, and I'm going to have multiple nitrates. So nitrate would need to be in parentheses, and then I would put the 2 on the outside of the parentheses. Now I already have some coefficients here, so that means I do need to pay attention to where I put these answers. And so I'm just going to go ahead and balance and see how it ends up, which one needs to go where. So everybody that I have present, I have rubidium, I have nitrate, I have beryllium, and I have fluorine. Rubidium count on the left, I have 1. On the right, I have 1. Nitrate left, no parentheses, no multipliers, so that means I have 1. Nitrate right, there are parentheses, and this multiplier is 2. Beryllium on the left, I have 1. Beryllium on the right, I also have 1. Fluorine left, I have 2. Fluorine right, I have 1. Minho says ions would come before nonmetals, so I'm going to go ahead and fix this nitrate here and go ahead and multiply that by 2. That would get me to 2 nitrates on the left-hand side, but also 2 rubidiums. Now, metals before nonmetals, so I have 1, I want 2, so I'm going to go ahead and put a 2 coefficient for the rubidium fluoride. That would fix my rubidium and my fluorine, so now I can go ahead and do my little victory laps. And I can see that, okay, this was the compound that had the 2 in front of it, so that means that this has to be where rubidium fluoride goes. And this compound does not have a number in front of it, which means it's an invisible 1. So that would have to be where the beryllium nitrate goes. And you can see that I didn't quite give myself enough room there, but that's where you would put beryllium nitrate in the blank there, and rubidium fluoride would go in the other blank. Balance the following reaction. So I have gallium fluoride and cesium reacting to form cesium fluoride and gallium. So I'm going to list everybody that I have present. So that would be gallium, fluorine, and cesium. Gallium on the left, I have 1. Gallium on the right, I have 1. Fluorine left, I have 3. Fluorine right, I have 1. Cesium left, I have 1. Cesium right, I have 1. So fluorine is the only one that's messed up here, so I'm going to go ahead and fix fluorine. I have 1, I want 3. I need to multiply by 3. And that fixes fluorine and messes with cesium. So now my cesium count is 3 on the right-hand side. And that means that now I need to go back and fix cesium. So on the left-hand side, I'm going to add a coefficient of 3. And that balances everything out, so I can go ahead and do my victory laps. Now remember, on blend, these blanks, the ones that I didn't end up having to add any special coefficients, those are invisible ones, but on blend, I do need to type the ones. Predict the reactants based off of the provided information. So I have 1 blank plus 1 blank goes to BA, F2, and PTS. So I can see that I am going to have something plus something going to a compound plus a compound. So this has to be a double replacement reaction, which means that I am going to be switching partners here. So that means that barium would need to be bonding with sulfur, and that platinum would need to be bonding with fluorine. I already have my set coefficients here, so that means that I have to keep the count the same on the left-hand side and on the right-hand side. So currently on the right-hand side, I only have 1 barium, so that means that my answer, I can only have 1 barium. And I only have 1 sulfur, so for my answer, I can only have 1 sulfur. Then for my second one, for platinum, on the right-hand side, I only have 1, which means that my reactant side, I can also only have 1. And for fluorine, on the product side, I have 2, which means on the reactant side, I also need to have 2. So I'm going to go ahead and give that a subscript of 2. And now everything is balanced, left side and right side. I have identified that this is a double replacement reaction and have appropriately swapped partners.